Good morning everyone, welcome to HashLearn, and for the computer awareness part of your examination, IBPS Clerk mains examination, we'll be looking today at the concept of binary arithmetic, ones and twos complement and logic gates. In the previous class, on the first session for computer awareness, I have discussed with you the binary number system and how to convert from binary to decimal and decimal to hexadecimal and all of those things. Also, we have discussed binary arithmetic basics like adding binary numbers or subtracting binary numbers, multiplying or dividing binary numbers, right? If you see the latest paper pattern of the bank examination, this is the new thing that has come up, that reasoning and computer aptitude have come together as one section, and this has been happening since 2017. And to understand how this paper pattern is, if you look at the IBPS PO examination, there also we have the same types of questions. So if there are, let's say, 50 questions from reasoning and computer aptitude combined, then 5 or 7 are from computer aptitude and the rest are from reasoning. So we can say the same thing for the clerk examination also. The IBPS clerk mains examination has 60 questions from reasoning plus computer aptitude. So you can rest assured that out of 60 questions, 50 will be from reasoning, the classical types of questions on syllogism and coding and puzzles and seating arrangement and all of those things. 50 questions, and 10 questions can be from computer aptitude. Now from computer aptitude, now they're not saying computer GK, rather they're saying computer aptitude. So in computer aptitude, there is a high probability that the questions will be from binary number system, conversion of numbers from one base to another, adding, subtracting, dividing, multiplying binary numbers, finding ones and twos complement of binary number, and also questions from logic gates. In addition to that, there are questions from DBMS basics like ERP diagrams and all those things that we'll be seeing in the future video lessons. So today's goal is to understand how to find ones complement and twos complement of binary number, and to understand a little bit more about binary numbers, followed by understanding different types of logic gates and the truth table and of the logic gates. So you'll understand that if you have not studied computer science in your school, in college, and you're completely unfamiliar with this, then also you don't need to worry. We'll understand things in a very simple way to make it very easy for you. Alright, so let's start with ones complement. Now we're not going to detail of what is ones complement actually used for and all those things. You're not appearing in a computer science examination as such. You just need to understand what is ones complement and how do we go about finding ones complement if you get a question in the examination. Let's say the question is something like find the ones complement of, find the ones complement of a number. The binary number is given to you, ones complement of 0 1 1 0 1 0. So let's say find out the ones complement of this particular binary number. Now for that you don't have to convert this into a decimal number or do anything of that sort. The easiest thing to do in this world is to find out the ones complement of a number. Take this number 0 1 1 0 1 0, and what you do is convert zeros to 1. How do you find ones complement? Convert zeros to 1 and 1 to 0. That's all. That's how you can find out the ones complement. So if you convert this 0 here to 1 and then this 1 to 0, so you'll get 0, then next this 1 to 0 and this 0 to 1 and this 1 to 0 and this 0 to 1. That is your ones complement. That is the ones complement. Now can there be anything easier than this? Don't worry about anything else. You're just going to see this question in the examination and you will solve this in 5 seconds. We'll convert the zeros to 1 and ones to 0, and that is what gives you the ones complement of a number. Right? Okay. Let's see what is the meaning, what are these numbers representing. If I calculate them into decimal, if I convert them into decimal, what do they mean? So 0 1 1 0 1 0, this value will be how much in the decimal system? Now this we have discussed yesterday itself, that leave out the zeros, just work with the ones. So this is 2 power 1 and this is 2 power 3 and this is 2 power 4. How do we get that? You see, if the position is 2, then power is 1. The position is 3, the power is 2. If the position is 4, the power is 3. If the position is 5, the power is 4. Count from here. 1, 2, 3, 4, 5, the power will be 4. So 16 plus 8 plus 2, that's equal to 10 plus 16, 26. And if you take this number, it's 1's complement, because you can also ask you to represent that 1's complement in a decimal form. So 100, 101, the position is 1, so 1 minus 1 is 0, 3, so 3 minus 1 is 2. Count from here, 1, 2, 3, 4, 5, 6, so 2 power 5. And 2 power 5 is 32, 2 power 2 is 4, and 2 power 0 is 1, so 32 plus 5, 37. So you can say that the 1's complement of 26 is equal to 37 when you find out and convert that into a decimal system. Next, let's look at what is 2's complement. Finding out 2's complement of a number. Let's say the same question we take. Find the 2's complement. Find the 2's complement keeping it as simple as possible, because just from the examination point of view, of 0, 1, 1, 0, 1, 0. So 0, 1, 1, just same number that we did in the previous slide. What will be the 2's complement of this number? 0, 1, 1, 0, 1, 0. So if you take here the first step, okay, let's write down the number here, 0, 1, 1, 0, 1, 0. So step 1, while finding the 2's complement, it's giving very simple. Step 1 in finding the 2's complement is to find the 1's complement. Find the 1's complement of the number. Okay. So what is the 1's complement of 0, 1, 1, 0, 1, 0? We have already seen that it's 1, 0, 0, 1, 0, 1. Once you find out the 1's complement of the number, step 2 is to add 1. Add 1 to the 1's complement. So if I take here 1, 0, 0, 1, 0, 1 and we add 1. Now what is 1 plus 1 in binary? 1 plus 1 is equal to 10. In binary system I am saying 1 plus 1 is equal to 10, and 10 means we get a 0 here and we get a carry of 1. So 1 plus 0 is 1, and this 1 will come down as 1, and they get 0 and 0 and 1. That is your 2's complement. Now if I convert the 2's complement into decimal number, how much it will be? So 1, 0, 0, 1, 1, 0. Now this is left out, so we will go with this 1 and we will go this 1 and this 1. So this is the second position, power is 1, third position power is 2, and 1, 2, 3, 4, 5, 6. You see 1, 2, 3, 4, 5, 6, so power is 5. So we get 32 plus 4 plus 2, that is 36 plus 2, 38. So you can see very clearly here that the 1's complement was 37. We have simply added this 1 to it. 37 plus 1, that is equal to 38. 37 plus 1 is 38. And 2's complement is largely used for the working with signed binary numbers. Now we have to understand just this one thing here. Okay, what are these signed binary numbers? Signed numbers. Little advanced concept of number system here. But signed numbers, for example, if you take 12 and you want to represent it in binary, so you say 2 into 6 is 12, the remainder is 0, 2 into 3 is 6, remainder is 0, 2 into 1 is 2, remainder is 1, and that's all. So we get 1 1 0 0. So 12 in the decimal base system, 12 in the decimal base system is equal to 1 1 0 0 in the binary base system. Clear? That's very easy to understand. Now we have discussed this in the previous session also. 12 in decimal is equal to 1100 in binary. Now the question is this: how do you represent minus 12? Because computer does not understand plus and minus, it understands only 0 and 1. So how do we represent minus 12 in the binary form? For this, what we have to do is we have to use the leftmost bit in the number, and by using 0 and 1 we can indicate whether the number is positive or negative. So you understand here, 0 is your plus or positive and 1 is negative in the signed binary number. So once we get here 1 1 0 0, on the left hand side we put a 0 here and we say 0 1 1 0 0 is equal to 12. Okay, we say that this is a signed number, this is plus 12, this is plus 12, okay, this is 10 and this is 2, this is positive 12. Now if I say 1 and I put 1 here, and we know this is 1 1 0 0, 1 1 0 0 in the binary is equal to minus 12. For that we should know that this is a signed binary number. So we should inform, we should program it accordingly in the system that we are working here with a signed binary number, so that the leftmost bit can be understood only as a plus or minus sign and not as converting it actually into its decimal form by multiplying with 2. Okay, so that's a little bit about signed numbers. So the reason why we take 1's complement here is that even if you get a negative number, when you find, let's say 1, when you take its 1's complement, it becomes 0, and therefore the chance of doing mistakes becomes less. So 2's complement is mainly used to work with signed binary numbers, addition, subtraction of signed binary numbers. And this is a little bit of information that I have shared with you regarding signed numbers. Remember, 0 is positive and 1 is negative. Clear? So not to go into too much in depth, that's not required for you. 10 questions are there, not much. If you get a question from 1's complement, 2's complement, 1 question you will get. You can solve very easily if you know how to find 1's complement and 2's complement. Again, let's quickly understand here. 1's complement is to convert zeros into 1 and 1 into 0. Don't use too much of your brain, just look at the number, convert 1 to 0, 0 to 1, you will get the answer, as we have done here to find out the 1's complement. And for 2's complement, simply 2 steps are there. Again, don't worry about whether the number is signed or unsigned, just look at the number, find out the 1's complement of the number as we have done in this particular slide, and find out the add 1 to it, and that will give you the 2's complement. That's all about 1's complement and 2's complement as far as you need to know from your IBPS clerk mains examinations point of view. Alright, now let's go to logic gates, which are used mostly in electronics systems. And what are logic gates? So let's understand the first logic gate here. Let's look at this gate here. A and B are the inputs. So what are these A and B? These are the input. We represent the logic gate using the diagram that you see. Sometimes it's also made like this, right? So this is the OR gate. Okay, so here C is the output. So A is the input and C is the output, and let's see, this is what is called as the OR gate. This is the OR gate. OR and gate. So OR gate basically is nothing but C is equal to A plus B, is addition. Whatever input is being given, we are going to add them. So if you say A is 0 and B is 0, then 0 plus 0, we know C is equal to A plus B. So 0 plus 0 is equal to 0, and if you take here A is 0 and B is 1, so 0 plus 1 is equal to 1. 1 plus 0 is also equal to 1, and 1 plus 1 is also equal to 1. Okay. So this is the truth table. This is what is called the truth table of the OR gate. Truth table. Check the values. So if we know what is the input, we can find out what is the output. So if A is 0 and B is 0, then 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1 is also 1. Is it? We are not working with binary decimal system where 1 plus 1 is 2. Here we are working in binary system. Okay. So that is the concept of your OR gate. Look at the symbol, look at the diagram, and understand that the diagram is that of OR gate. Okay. So it's more like this in the actual picture. Okay, A and B, and this is C. Okay. Next we'll look at the second gate, which is the AND gate. It's like a D, as you can see here. This is the AND gate. The OR gate, and this is the AND gate. So it's like just like a D, and we have two inputs here. Again, A and B are the input values. A and B are the input values. And the output is here C. C is the output. And you should know here that again C is equal to A into B. So OR is addition. So you understand this. OR is addition and is multiplication. OR is addition and is multiplication. If you remember from your mathematical concepts of permutation, combination, or probability, there also we do OR as addition and and as multiplication. So what will be the truth table for the AND gate? Truth table. So if you know, multiplication is very simple. So A is 0 and B is 0, so 0 into 0 is 0, 0 into 1 is also 0, 1 into 0 is equal to 0, and 1 into 1 is equal to 1. See here in electronic system, zeros and ones represents on and off. 0 is off, 1 is on. So think of it like a bulb is there, and there are two switches attached to that bulb. One next to the bed, one next to the table, and both of these switches control the bulb. So if both the switches are on, then only the bulb will be on, if that is the way we want to program it, right? That is the way the AND gate works. But unless until both these switches are on, the bulb will be not on. If any one switch is off, the bulb will be off. The reverse here is that in the see here in the in the OR gate, that we have seen, OR gate is the addition part. There 0 0 is 0, 0 1 is 1, 1 0 is 1, and 1 1 is 1. So in the OR gate we are saying that if any one switch is on, at least one switch is on, the bulb will be on. The bulb will be off only when both these switches are off. This zeros and ones not like numbers here, it's more like off and on. Okay, that is the AND gate. And next is to understand this gate. So this is what is the name of this gate. Suppose this question comes in the examination. First of all, there should not be two inputs here. Let's correct it a little bit here. So we have one input and one output. So here we have the input, and here is the output. This is called the NOT gate. NOT gate. Basically what it does is it reverses this input. So again we don't need to do this truth table here. Simply to understand for NOT gate, when input, let's say input is A and output is B, when A is 0, B is 1, and when A is 1, B is 0. That's all. That's all we need to understand regarding the NOT gate. It is going to reverse. If you put 0 inside, then if you put input as 0, then the output will be 1, and if you put the input as 1, the output will be 0. Okay, that is the NOT gate. What is the name of this gate? NOT gate. Now how can we combine these gates together? So we have seen 3 gates till now. One is the OR gate, one is the AND gate, and one is the NOT gate, right? So there are 3 gates we have seen till now in terms of the logic gates. Now how can we combine these gates? So let's say if I take the OR gate, now you can very clearly see that this gate that you see on the screen here is the OR gate. Now if you put a 0 next to it, that is representative of the NOT gate. So what are we doing? We are combining OR and NOT, and this is what is called as the NOR gate. See, the name is very indicative. We are taking the OR gate and the NOT gate and we are combining them. So understand that this is the NOT gate. If you look at the 0 here, this is the main signal here to understand. Okay. Now this is the NOR gate, and we have 2 inputs here, A and B, and the output is C. So what will happen here? Now if you recall the table for the OR gate for A and B and C, what was the table? Now 0 plus 0 was 0, 0 plus 1 was 1, 1 plus 0 was 1, and 1 plus 1 was 1. This is the truth table for the OR gate. So what will happen if it is a NOR gate? Now you see 0 and 0 is, let's just fill this first, 0 1, 1 0 and 1 1. Now remember, what does the NOT gate do? NOT gate is going to reverse the output. Whatever if you put 0, it converts it into 1. If you put 1, it converts into 0. So when it's 0, it will become 1. When it is 1, it will become 0. When this is 1, it will become 0, and this is 1, it will become 0. It reverses the result of the OR gate. When you put a NOR gate, when you put, let's say, NOR gate, it reverses the result of the OR gate. Clear? That's how you should understand it. Now next, we have already seen what is OR gate, what is AND gate, and what is a NOT gate. And it's just again to reiterate, the NOT gate is always identified by this 0 that you put after the gate. Now let's look at this diagram here. Now this is a diagram that you can clearly recall, we have just discussed now, is the AND gate, and when you put a 0, that's a NOT gate. So when you combined AND and NOT, it becomes the NAND gate. This is what we call as the NAND gate. NOT gate plus AND gate is NAND gate. So if you take 2 inputs here, one is A and one is B, okay, so you already have the inputs here A and B, and the output is C. What will the output be? What will be the truth table? What will be the truth table for the NAND gate? Can you work it out? Now that you have understood how did we convert the OR gate into NOR gate, can you work out the output for the NAND gate? Okay, let's see. So first what we'll do is we'll rewrite the truth table for the AND gate. So in AND gate, now we know what is AND gate. AND gate is multiplication. So if we have A and B and C, then we have 0 into 0 is 0, 0 into 1 is 0, and 1 into 0 is again 0, and 1 into 1 is 1. This we know very well from our truth table of the AND gate. So if we apply this here, what will happen? 0, 0 should be equal to 0, but what happens when we have the NOT gate? The NOT gate converts zeros to 1. See, we are doing this slowly, clearly for you to understand how it works out, and 1 to 0. So 0 plus 0 was 0, but the NOT gate here will convert this into 1. So it will become 0 0 1. Clear? Now I am sure that you are following now very clearly. Let's take 0 and 1. So for 0 into 1, the result was again 0, but since this is a NAND gate, not just an AND gate, it is NOT plus AND, AND plus NOT, you can say AND plus NOT, or NOT plus AND. Okay, so the 0 will again become equal to 1. Now 1 into 0 was 0, so 1 into 0 was 0, but again it will become equal to 1, and 1 into 1 was 1, but then 1 becomes equal to 0 because the not part is added here, so it will become 0. This is the truth table for the NAND gate. So you see, we have discussed now that makes the total number of gates discussed here as a part of your understanding for the IBPS clerk mains examination. We have discussed 5 gates. So what are the 5 gates? One is the OR gate. Remember, OR is addition. Okay, OR is addition. Quickly, if you make the diagram of the OR gate, this is the diagram of the OR gate. Looks like a kite. Okay. Now next is the AND gate, and what is AND gate about? AND gate is about multiplication. AND gate is a multiplication. And what is the symbol for AND gate? It is a D. That is a symbol for AND gate. Just remember the word AND ends in D. AND gate looks like D. That will help you never forget the gates ever in your life. AND gate ends in D, and AND gate looks exactly like D. You can see here, it looks exactly like D. Now then the NOT gate is the reverse gate. No? You put one input and you get one output, and you convert 0 to 1 and you convert 1 to 0. Now when you combine the OR gate plus the NOT gate, it becomes equal to the NOR gate. And remember, just we take the NOR gate here and we put a 0 at the end. So that is your NOR gate, that is OR plus NOT. So you take the truth table of the OR gate and reverse it, right? Reverse the output. Zeros become 1, 1 becomes 0. And when you take AND gate plus NOT gate and you combine them, that is when you get your NAND gate, right? So you take the AND gate, which is like a D, and put a 0 at the end. That is your NAND gate. Okay. So in this session we have looked very carefully at 2 of these concepts that are not commonly known by students who are not from pure computer science background. So if you have done your BSc in computer science or a BCA or MCA or a BTech in computer science, then you must have studied these things in your first and second year of your engineering. If you have not been from computer science background, most of these things are new to you. So don't go into in-depth understanding right now what are these gates and how they are used in logic design and electronic circuits and all those things. That is not our purpose. Right now we are not studying here logic gates with the purpose of understanding electronic design or logic design as it called. We are just saying, okay, look at the diagram, remember that much, and that's all. No? What you remember is the AND gate. Remember, AND ends in D. That's one thing, and NOT is a 0, convert it opposite 0, and that will make you remember these gates. You get a one question from gates in your examination. You look at the paper when it comes on the day of your examination in the IBPS clerk mains examination. Look at the reasoning section and you will see that there will be one question from the logic gates, and the logic gates question will be from just these 5 gates. You get 1 mark just like that, and if you remember this much, 1 mark is guaranteed for you. And there will be one question from 1's complement and 2's complement. So you will say almost 90% surety that 2 questions will come in the examination based on this 1's and 2's complement, 1 question, and then 1 question for sure from logic gates. Alright. So I hope you have followed whatever we have discussed in simple ways, in simple terms in this session today. And if you do this much, you have a very good chance of doing well in the computer science questions that you get in your IBPS clerk mains examination. Alright. Now we will continue later on with other videos on computer awareness. We will discuss about the entity relationship diagrams and database management systems and some of the important concepts about internet and email and computer security. Today's session was about binary arithmetic and logic gates. So now is the time for the class practice pack, in which you have 10 questions from the topic that we have discussed today. Those who have passport access should start solving the questions immediately. The doubts, if any, will be discussing in the future sessions. So best of luck to you for your examination, and keep watching the video.